In this lesson, we're going to see how we can use Avogadro's number and the molar mass of a substance to convert among values of mass, moles, and number of particles. So we learned how to calculate the molar mass. Now we can use the molar mass like a conversion factor or a relationship. Just like we use relationships between metric prefixes or other units, so say 12 inches in a foot, we can use molar mass as a relationship to convert between grams and moles. Just like with our other relationships or conversion factors, we can invert the relationship in order to make our units work out correctly. So we're going to be using the same ideas that we used previously with dimensional analysis to solve these problems. For water, the molar mass is 18.02 grams per mole, and this can also be written as 1 mole over 18.02 grams, depending on what we need to be able to cancel out and solve for our unknown value. So let's look at an example. How many grams are in 2.25 moles of water? Just like our earlier problems with dimensional analysis, we have to figure out what units we're starting with, what units we want to end with, and what relationships we know that will help us convert between them. In this question, we're only given one numerical value, which is 2.25 moles, so that's going to be our starting unit. Note that it's a simple unit, it's just moles. And it's asking for grams, so that's going to be our end unit. And we have to look at the relationships between grams and moles for water. So in this case, we would actually have to calculate our molar mass of water to be able to solve this problem. So we're going to start with our first value, which is 2.25 moles of water. We know that we want to cancel out moles, so moles needs to go on the bottom of the next step. And so we put moles on the bottom and the grams on top. We'd already calculated the molar mass of water as 18.02 grams per mole. Now our units of moles cancel out. At this point we're left with units of grams, and now we can take 2.25 times 18.02 and get 40.5 grams of water. Notice that the process I used here was exactly the same as the process I used in solving dimensional analysis problems. The only difference was the relationship was specific to water. Another relationship which we can use is Avogadro's number as a conversion factor. In this case, we have 6.022 times 10 to the 23rd something per mole. Just like with our molar mass, we can invert that depending on what units we have and what units we need. And in this case, we need to figure out what goes in for the question mark in that relationship. Remember that Avogadro's number is a counting number, so that question mark can actually be just about anything. Remember that if we have 12 books, we can call that a dozen, so we could say 12 books per dozen. We could say 12 people per dozen, 12 eggs per dozen, or 12 cookies per dozen. It doesn't matter what the thing is, the term 1 dozen always means 12 of whatever that is. The same thing is true for Avogadro's number. When we say we have a mole of something, we're saying we have 6.022 times 10 to the 23rd, whatever those things are. So we could actually use anything we want in that relationship. Now most often what we're going to be using is going to be atoms or molecules, because that's what's going to be useful to us as we're solving chemistry problems. It's not useful for us to talk about having 6.022 times 10 to the 23rd eggs per mole, although we certainly could if we wanted to. How many molecules are in 2.25 moles of water? So in this case, we're starting with moles and we're trying to find molecules. Because the problem is asking for molecules of how many of those things do we have, now we're going to use Avogadro's number. In the previous problem, we were looking at the relationship between moles and grams. In that case, we have to use the molar mass. Here, we're looking at moles and molecules, so we're going to use Avogadro's number and not use the molar mass because grams are not involved in this problem. So we start with our given value of 2.25 moles of water. We know that we want moles to cancel out, so it's going to have to go on the bottom of the next step, and we'll have Avogadro's number on top. And because we're talking about molecules, it's going to be 6.022 times 10 to the 23rd molecules per mole. Moles will cancel, and we're left with units of molecules, which is what we're looking for in the problem. And now we can calculate 2.25 times 6.022 times 10 to the 23rd molecules. A couple of abbreviations that are useful to remember. MOL represents moles, MOLEC stands for molecules, and M stands for meters. We have to be careful with our units to make sure we're setting our problems up correctly and getting to the right units for our answer. Now, we could also go in the reverse direction. We could have grams and convert to moles, or have molecules and convert to moles. And so this diagram shows us something about the relationship between all of these values. Notice that between grams and moles, we use the molar mass, which has units of grams per mole. And we can use this whether we're going from grams to moles or moles to grams. To convert between moles and molecules, we're going to use Avogadro's number, which has units of molecules per mole for this case. And again, we can go from moles to molecules or molecules to moles using this relationship. We're also going to see an example how we can go from molecules to atoms, and we do that from the chemical formula by looking at the ratio of the subscripts. And we there have units of atoms per molecule. So we can interconvert between any of these values, but we have to do it in this order. So if we're going from grams to molecules, we first have to go from grams to moles and then moles to molecules.